Hello, and good evening. Sorry about the late start. Something to do with Wi-Fi. That always works, though, right? So this is Scale 13. I want to start by wasting a little bit of time, not in a waste, but in a genuine, gratuitous, not gr- uh, with genuine gratitude. That's what I meant to say to all of the organizers and staff who have worked so hard. This is a 13-year-long labor of love. Let's give up a round for all of them. So I am Dead Program. In the real world, my name is Ron, or Dad, but that's not important right now. I am Dead Program for the context of this conversation. And I'm the ringleader of Hybrid Group. So the strong silent type here is Zankich, known as Adrian. He's the serious programming guy at Hybrid Group. So the Hybrid Group is a software consultancy based here in Los Angeles. Some people have called us the software company that makes hardware companies look good, which was very kind of them. Among other things, we're the creators of Kids Ruby, which is a free and open source tool for teaching kids to program using the lovely Ruby language. But that's pretty much the end of Ruby for this conversation. We're here to talk about full stack robotics. Yes. You have no idea how hard it is to find an animated GIF of a pancake making robot on the internet. But believe it or not, we're actually talking about this kind of full stack robotics, the big picture. So when we say full stack, we don't say it with the irony we perhaps should. But what we're really talking about is the patterns, practices, tools, and frameworks that one is going to use to build some kind of application. In our case, we're talking about physical computing, or as it's trendily known today, the Internet of Things. We just think of it all as robots. So there's four different layers to the stack. The first one is the front ends, which is how human beings interact with the machines. For that, we have a few different open source tools of our own. Commander, which is a mobile app it's like a universal remote control for robots. We're going to see that in a bit. Robo, which is a single page Angular app. Like a router has a built-in admin page, we think robots need the same thing. WatchBot, which is how your Pebble watch can interact with robots. And then, of course, the custom app, which is the reason why you're building some kind of robotic solution in the first place. Then we've got our frameworks. So a framework is a collection of libraries that are well designed to work together to actually build something useful. We're going to be showing a few frameworks today. We have Cylon.js, Gobot, and R2, and then Gort, which is a command line tool for connecting to robotic devices. Then there's the integrations. Those are APIs, vendor libs. Sometimes they're proprietary, sometimes they're open source for how we actually talk to the hardware devices. And then the things themselves. And those things we divide into three categories. We have cloud things, which are things we're talking to somewhere else. Hardware things that we're actually connected to physically that are here present. And then software things. Something like a software thing might be OpenCV, which is a computer vision processing library, which is very, very robust platform all to itself. So that's kind of the big picture. And today we're going to be starring Gobot. So since the last time that we spoke here at SCaLE 1 year ago, we released Gobot, which is a robotic framework written in the Go programming language. And of course, we're also going to bring our old friend Cylon.js, which is robotic programming using JavaScript. So a quick review of the design patterns that both of these frameworks use, just so you understand what you're seeing. So the primary thing we care about is the robot. So robots have connections, which are talking to some sort of physical device via adapters. The same way that your database may have an object relational mapper that can talk to different kinds of databases, PostgreSQL, MySQL, whatever. We have the same sort of principle applied to physical computing. And then we have devices. So a connection would be a different kind of platform, like an Arduino or a BeagleBone Black. Devices are things like buttons or LEDs. So we can use the same LED driver on an Arduino, on an Intel Edison. So the idea is that we can use modern principles of layered software design to build our architectures. And that's the internal API. Here's the external API. Since what good is any kind of robotic device if you can't program it over the intertubes, right? So we have an API built in. It talks to what we call the Master Control Program, or the MCP. And the MCP talks to all your robots. This is how you can control a swarm of robots. And then you can connect to our API either using a RESTful API calls, using WebSockets, using MQTT. There's different ways that you can talk to it from outside. All right. So how about something real? We always start with an Arduino, the minimum viable microcontroller. and we're going to show you the Arduino running some GoBot code. The GoBot code is running on the computer, and then we're going to be connected to the Arduino via a cable. So here's the code. And so anybody here program in the Go language? Excellent, an introduction to Go. So Go is not an object-oriented language, but it looks a lot like one. It is a compiled language. It's strongly typed, and it's statically linked. So it looks a little bit more like C++ and Java had a love child, and that love child was beautiful. So what we do is we import libraries, and this is the same sort of thing you do with requiring gems in Ruby or requiring modules in Node. So we're bringing in the time standard package, and then we're bringing in the GoBot packages for GoBot itself, for Fermata, which is how we're going to communicate with this Arduino, and then the GPIO pins, which is how we're going to control the LED. By the way, what we're doing here is we're making a blinking LED, the hello world of physical computing, if you will. So here's the main program. So first we're going to create a new GoBot, which is basically the master. And then we're going to declare the Fermata adapter, which is going to be communicating on this serial port, which is a very common one to Linux users who've used any kind of serial interface. Then we're going to bring in the driver for the LED connected to pin 13. And then the work that our robot is going to do is that every 1 second, we're going to LED.toggle, which will turn the LED on if it's off or off if it's on. Then last, we declare the robot itself. We say that it's got one connection to the Fermata, one device to the LED. Here's the work it should do. We add that to our master, and then we start. So I am a very unskilled camera person.
So here's the Arduino right here, and we can see it's plugged into my laptop here. So right here, I just have a very simple LED circuit. Nothing too special here, so I'm going to run the Fermata program. So it's initializing the Fermata right now. And it blinks.
Gratuitous applause. So if you haven't seen a blinking LED on an Arduino, you haven't been alive in the 21st century yet.
Yeah, so you're welcome.
All right, let's move on. Let's get to Linux. That's why we all came here. The BeagleBone Black. Who here has heard of the BeagleBone Black? Yay! I think Jason is here somewhere. The BeagleBone Black is an amazing single-board Linux computer. It's based on an ARM processor, and it has 68 pins of input and output. It's quite powerful, quite fast, and quite inexpensive. We really like them a lot. So we're going to be showing you the same kind of blinking, exact same kind of blinking. So this program looks almost exactly the same. We're still bringing in time. We're still bringing in GoBot. This time the BeagleBone adapter. Still the same GPIO interface, though. So we declare a new robot. This time we say use the BeagleBone adapter. And we say use pin P9_12. In all of our frameworks, the thing you put in your code is exactly the same as the way the board itself is labeled. For anyone who's ever tried to do this and you're like looking on the table to see pin 37-5 is actually B6-3, and it's too much work. So everything is labeled exactly the same as you use it in our code. So then same thing, every 1 second we toggle, we declare the BeagleBone adapter in the LED, and then we start. So there's the BeagleBone. So
yeah, here's the BeagleBone Black. Right now it's connected to my computer purely to power it and use the Ethernet over USB. So I'm actually SSH'd into this Linux computer from my laptop. So just to show you how there's no trickery here, the same exact circuit that we used for the Arduino, I'm going to plug that directly into this BeagleBone Black. So this is going to be
where the labeling thing is really useful.
Yeah, so this is going to go into P912. So first we're going to put in our ground in here, and then we're going to do a little counting. So 2, 3, 4, 5, 6, 7, 8.
By the way, if you've never messed around with electronics, the red one is hot, and either the black or white one is ground.
Yeah.
We just take this for granted. We had no idea that people didn't know this.
Yeah, so another tip. So let's run this program. Say that again?
Ah, yes, high voltage. That's a whole nother seminar.
I know.
I mean, you don't think my hair started out this way.
So then
Listen,
now
we've all been burned by something we love.
So then now I'm going to run this program on the BeagleBone Black itself. And it blinks.
Now look how fast that was.
So for the Arduino, this was plugged into my laptop using a remote serial interface. For this example, the code is actually running on the board itself. So you're programming the firmware for your connected device on the device itself. So this does not need any outside system to coordinate or control it. It's completely autonomous.
All right. And the code, remember, this is the code for, let's go back. This is the code for the Arduino. This is the code for the BeagleBone. Arduino, BeagleBone. You see, it's basically exactly the same code. There's only 2 or 3 lines of code different.
So you can prototype on one board, like an Arduino, and then when you're ready to install your installation, you can easily switch from an Arduino to a BeagleBone Black, only changing a few lines of code, mainly what library you import and how you actually initialize the connection to that board itself.
Exactly. All right. Let's move on. Part 2, Bluetooth Low Energy. All right, so now time to introduce Commander. Commander is an open source application that we released last year. It's written using PhoneGap, which is an open source framework for developing hybrid mobile apps using JavaScript. And it uses Ionic framework, which is a framework for mobile development that is written based on AngularJS. So it takes advantage of our API. We have something that we call the Common Protocol for Programming Physical I/O, or as we call it, C3PO. Now, we don't have 9 million forms of communication yet, but we're getting there. So the way that C3PO works is it provides a common interface for talking to the robots and their devices, and we're going to take advantage of that with Commander.io. So we're going to show this demo using an Intel Edison and a Sphero Ollie. So that's a Sphero Ollie, and this is the Edison, this little tiny guy here. This is the latest single-board Linux computer from Intel, and let's see if take a look at it closely. I don't have much cable. And the battery.
Oh.
Okay, you be my cameraman.
So that's the Intel Edison. So it's actually in its mini breakout shield, so you can see that the slightly different color blue surrounding the other color blue is an external mounting shield for it. So that gives us the USB ports and some pins or holes for prototyping. Now there's different breakout boards that you can use for the Intel Edison. So unlike the BeagleBone Black or the Arduino, where it was a single pinout, the Intel Edison you can have multiple pinouts depending on your application.
All right, so let's see if the demo gods continue to favor us with their presence. All right, the Ollie's turned on. You want to put it down on the floor?
Yes.
Excellent. All right. So,
let me get this camera to.
Yeah, I don't have a lot of cable.
This is our video adapter.
It works every time, mostly.
This is how you know it's real. There you go. Right. Oh.
It's just a little too real.
I know.
All right, so let's see if I can get my all-cast application to work here. Because we don't have enough moving parts yet. We need more.
Yeah. Presentations are so boring when you just have slides and your computer and, we needed more pressure.
Oh, these are not on the same Wi-Fi network. Okay, well, you won't be able to see my phone unless I hold it up to the camera, but that's all right. We'll do it that way. Really old-fashioned. All right. So what we're going, let's briefly take a look at how this works. So we're going to be running JavaScript code now. So context switch. Not all you people who didn't know Go, well, you do know JavaScript. So no excuses, people. No excuses.
And if you don't know JavaScript, then welcome to be confused.
All right. So we require Cylon. So that brings in Cylon the same way that we're requiring that we were using the import for package GoBot. And we're using Cylon's API. Cylon has a modular API, so we're using the HTTP, and we're saying SSL false. The default is true, people. Security on your embedded devices. Need I say more? All right, so now we declare our Cylon robot. Its name is OllieBot. It has one connection that's using Bluetooth LE, actually, And this is the UUID, Bluetooth Low Energy Devices, have a unique identifier, each one of them, and this is how we're going to connect to it. And then we use the OLLI device. And so what we're going to do is we are going to have a move command. The robot itself has a move command, and it can take a direction as its parameter. If it gets up, it'll roll forward. If it gets down, it will roll back. If it gets left, it will actually turn red and spin around. And if it turns right, it'll turn red and spin around in the other direction. Then after 1 second, it'll stop. That way we don't lose control. We don't want to roll over you fine people in the front row, sitting on the floor. And then we declare a command. Because we may not want to expose all of the functions that are in our robot to the external API, we can declare that only this one. And then our work routine, remember the same thing that we saw before in GoBot. In this case, our work routine is first we tell the OLLI to wake up, and then after 200 milliseconds, turn colors. So that's what's happening right now. So the way that our Commander app, which is the mobile app, is going to communicate is in Commander, we have a JSON file called a command set. And that's how we define the user interface. I'm going to be using the D-pad style control because that's ideal for this kind of rolling device. And so we say that there's commands. The up command will tell the OLLI bot to move up. And this creates the ability to have a declarative file so that we can package along our commands along with our robot code so that if you're using commander.audio, you can just talk to it. All right. So let's see if this actually works. This will be fun. Didn't get to try this before. I'll walk over here so you can hopefully see something. So there's Commander's D-pad style interface. And let's see what happens. Yes! It moved! Oh, right. This is why I'm not on the AV crew in part. Only a small part, though. Oh, hey, let's go the other way. Oh, let's keep going. It's coming for you. Oh, wait. No, come back this way.
I know.
Something like that.
I'm so scared right now.
All right. So now let's make it spin. Oh. We're going to end up on the first floor anytime.
I know.
Okay, ready for takeoff, anyone? No, that's coming. That's coming next. All right. Applause, please. All right, more robots. More robots. So little time, so many robots. So this is the MIP. This is from our friends at Huawei, famous for creating the Robo Sapien. There we go. So this is a two-wheeled self-balancing robot. Uses the same technology as the Segway, just in a much, much smaller package. Please don't stand on it. I only have a couple of these. All right, so let's run the code. What's it called again? Oh, yes. So we're going to run the same exact Commander user interface, except this time it's going to be commanding the MIP. You see a pattern forming of patterns? That's how meta we are. All right, so let's see if this works. It's wandering around on its own. It's called roam mode. It's looking for a friend. It found one. And you know what it does when it finds a friend? It gets really happy. And of course, it's doing the robot. Boy. All right. So that concludes the Bluetooth low energy section of our demonstration. It all actually worked. Wow, this is cool. All right, part 3. Well, actually, before that, it's time for our ever popular Choose Your Own Hardware adventure. Woo! So now comes your opportunity to win some wonderful gear thanks to some of our wonderful friends. All you have to do is take out your mobile device, connect to your Twitters to win a Sphero 2. Actually, I think it's a 1.0, but it's brand new in the box. That's all you need to know. Sphero, tweet Go Sphero and CylonJS. That's Go Sphero and CylonJS to win a Sphero. It's going to be completely random and arbitrary. You can tweet as many times as you want. To win a Spark Core, which we actually don't even have time to show today because we have too many pieces of hardware, but it's an amazing Wi-Fi connected microcontroller from our friends at Spark Devices. Absolutely fantastic device. So to win one of these, tweet Spark_IO and CylonJS. So those Twitters again. To win a Sphero, tweet Go Sphero and CylonJS. Or to win a Spark Core, tweet Spark_IO and CylonJS. All right, on with the show. So for us, it all starts with a customer, and I know it's like the problem with open source is someone has to pay for it. And so we actually go around and we do work for companies, and they give us money, and then we turn around and create open source software, which we give to all of you wonderful people. It's a very inefficient form of wealth redistribution. So we did a project for a very, very publicity-averse company that we can only refer to as Consumer Products Company. Consumer Products Company does, shall we say, they are very involved in the business of the dispensing of beverages. So we built something for them, and then because we can't actually talk about it, we built something completely similar but yet different that uses totally different technology to show you the same concept. All right, we call it Brew Machine. Brew Machine. So Brew Machine, it works kind of like this. So we're going to show you an Intel Edison that is connected to a drink pumping mechanism. It's going to give us notifications on our Pebble watch. We're going to be able to dispense beverages using our Commander app, and then we're going to have a delivery drone. All right, on with the show. We're going to control all of this using MQTT. So MQTT, it originally stood for something like message queue telemetry transports, but now it's an acronym without an acronym. It's basically a machine-to-machine messaging protocol. It was in November, it was approved as an OASIS standard. So if you're doing a machine-to-machine communication, you should not be using web protocols. You should be using protocols designed for this. And so let's start with the drink dispenser. So we're going to show just the Intel Edison talking to GoBot. We're going to use MQTT as our message transport. And we have a Heroku application. Let's take a look at that real fast. I got to make it smaller so you can actually see it. So this Heroku app is basically tracking our dispensers and our drone fleet. And so we'll actually see our notifications come online because it's connected to our MQTT. All right. So here's the code. So it's in Go. So our main package, we import a few standard packages for URLs. We bring in GoBot. The GPIO, which is how we talk to our digital and analog input and output. That's how we're going to turn on the pump. The Intel IoT Edison adapter, which is how we know how to talk to the Edison specific hardware. And the MQTT adapter. That way we can talk to our message queue. And so our main function, we create our master. We create a new adapter for the Edison. We create our MQTT adapter, and it's talking to this port, and it's named pump. Then we have 3 different devices. The lever, that when we push it dispenses a beverage. The fault button, which is what we push to simulate a fault because we don't want to disassemble our assemblage. And then the pump itself to turn on so we can dispense beverages. So the work we're going to do, we create a datagram, which is the message packet that we're going to send on the MQTT message bus. It just has got what dispenser it is, what drink was dispensed, etc. Then this is the first of the MQTT messages. If we get a message from outside to start the pump, if we're not already pumping, then we're going to start pumping, and we're going to send a message that we did. And after 2 seconds, we're going to stop. That way we don't overflow the drink receptacle. So then...
Overflow bugs, man.
Ooh! There's only one way to solve this buffer overflow, and I think Hewlett Packard had the answer down at their beer station. All right, so that's the technology we can all get behind. All right, so there's also we can simulate a fault by sending it a MQTT message for our fault, and we can do the same exact thing when we push the fault button. So whether it's the internal or the external API, it's the same thing. Then we add that to our robot, and then we start. Oh yeah, the video.
This is how crazy we are. We have open containers of water next to electronics. So, yeah, we're,
You don't know how many days start with that. How could anything go wrong?
I know. Oh, let's just put some water next to it.
Here, be careful, because I think it's hooked under your chair leg.
All right.
All right. You take care of your cables, and they'll take care of you. All right.
So this right here is the Intel Edison. So before you saw the Intel Edison and the mini breakout board, which we had the Bluetooth Low Energy demos running on. Now this is in the Arduino compatible shield. So you could see that, so just for size reference, here's the normal Arduino, and here's Intel's interpretation of what an Arduino is.
And here's Intel's interpretation of what a non-Arduino single board Linux computer is.
Yeah. So, you know.
Yeah.
So let's see. Right here you see I have a breadboard to simulate the buttons, and I've got my pump station here, and yeah.
All right.
So we're going to show a pump.
Let's do it.
All right. So
prepare to dispense beverage.
I'm not sure if we can.
Oh, that's the one button they don't put here. Oh, yes.
The screen?
I see it. I got it. Don't worry. Hey! Technology and science. All right. I don't know why some people like technology but not the science part. Anyway, moving on. When we want to go drinking, it takes us a while.
Yeah.
But it's worth it. Do you need a light?
Who needs light? No, I got it. I think I got it here.
I have a light on my phone. It's a very expensive and inefficient flashlight, but
yeah, let's see.
Actually, all right, now I'm the cameraman and the grip.
Let's see. So remember how we were saying that sometimes let's see if this works. No, this one's not working. So you remember how we said red is hot and white or black is ground? Well, this pump has a red wire, a white wire, and a black wire. Guess which one's the data?
You've seen the abyss. You know what happens.
Yeah. So let me see here. We got a little problem with the Stalin.
Small problem. Small problem.
Yeah. Let me look
so
at
as
this
I was
here.
saying, yes, we met a lovely programmer in London. She had flown up from Australia, did a great talk on getting started with robotics, and some of the points that she made were really hit home with us, including the wires thing, because a lot of people, they want to get involved with, they don't necessarily want to solder, but they're, breadboarding. What's a breadboard? How do you stick it in, like, which hole is which, and wait, which color wire? I mean, they all look the same to me. They're all, like, different rainbow colors. What is it? It's really, really difficult if you don't know which thing is which, and the system is quite simple, but that first step is often very difficult, and we really liked your presentation because it brought that point home. Some of us, we sort of take for granted things that we learned, in 7th grade electronics class, and, others, they just never had that opportunity. So it's, are we ready?
Yeah, for some reason this one's not, the pump's not activating.
That is a really good point. Yes. So if you don't know what a multimeter is, it's something to test whether or not there's a voltage. I
Hmm.
have a great multimeter that is actually Bluetooth low energy only. It has no display. So you have to use it with your smartphone. It's really, really cool from a Mushi meter, it's called, from Dragon Innovation. All right.
Yeah, for some reason this one's not. Um, it's
You
not
need more
doing
light?
it. No, I don't think so. I just need a little bit of time.
What's funny is we thought the Bluetooth low energy would be the problem.
I know.
Like, yeah, we've done the pump a million times. Yes. Tweet Go Sphero and CylonJS if you want to win the Sphero. I'll actually go back to those pages. How's that? Yes. The reason why we do this is we're really bad at finding people. So to win a Sphero, tweet Go Sphero and CylonJS. And or to win a Spark Core, tweet Spark_IO and CylonJS. You can't win both. Sorry. But if you don't win, just come to our booth, booth 7, tomorrow, and give us like either your business card or your email address on a small scrap of paper, which we have small scraps of paper and pens. Just because we need a way to track you down and tell you whether or not you've won, because we have another Sphero that we're also giving away. That one we will give away end of the day tomorrow. Actually, wait, I take it back. That was what we were going to do when it was all electronic. Now that it's small scraps of paper, we will be notifying the winner via email sometime next week when we come up with a really good OCR algorithm. Yes, a question. Oh, oh my God, I can't believe it.
It was Sarah Hui.
Yes,
Yeah.
thank you. If you go to Full Stack London, she's listed. She was the first speaker on the second day. Yeah, there's actually a really interesting. I know that here in the States we have a lot of problems getting women to stay involved in engineering careers. Strangely enough, several of the best electrical engineers and firmware people I know are women from down under. I don't know why that is. It's like very
From
odd.
Australia.
There's no correspondence to the real world. For example, Jenna Fox, Blueby, who wrote the firmware for this little tiny microcontroller we're going to show you in a minute, the Digispark. Anyway, on with
Yeah,
the
we're
show.
ready to go now.
Ready to rock.
So, it was a problem with the internet, believe it or not.
The internet is down.
Yeah. Yeah. The tubes were crossed. Okay, so let's push a button here.
Push a button.
Now, let's get started here. Did you guys hear it? Yeah? So then I just pushed the button to serve a beverage, and if we look at my Pebble watch, kind of hard to see. Let me find it. Homing. There we go. It says here, customer served, and then that very tiny little dot says 2. So then let's serve another customer. And I just got a new notification. So now 3 customers have been served.
Because it's really, really important sometimes to know every single time a beverage has been dispensed. Like if you're in the business of dispensing beverages, for example. So we actually skip forward in this section to our Edison, Pebble, and MQTT, which uses WatchBot, which is a Pebble application that we've written specifically for controlling robotic devices. You can find out more at watchbot.io. This is how it worked. And this was the code. The only really, the interesting part here is that we actually have the Pebble robot, which is communicating via one set of messages on our MQTT server. And then we also have the headquarters robot, which is dealing with whether or not the pump has been pumped, messages have been received, etc. All right, we saw that. Mobile control. So now we're going to show the Edison with the Pebble with Commander. So remember Commander? We saw that before. We're going to add that into the mix.
Do you have that one on your phone?
Yeah. No. Actually, I forgot to install that one.
Let me see. I should still have it on here.
Yeah.
Let me see here. This is what happens when you have trays of apps. It's really hard to figure out what's going on.
I need an app for my apps.
I know.
I've seen that happen with like Google Hangouts, where it's just like infinite Hangouts all the way down. If that happens on my phone, I'm just gonna run. Yeah, exactly.
Let's do a little.
So the interesting part here is that we're adding commands to the robot to pump and to simulate a fault. Remember, we were talking about how you may not want to expose all of the functions of your robot's external API to anything that wants to call it. This is just good interface design applied to robotic systems. All right.
I don't have commander installs on that.
All right. Well, we'll move on.
You saw it with an ollie. That's way cooler than
Let's
pumping
get to the grand finale, drone delivery. So there you are in the business of dispensing beverages, and then this terrible thing happens. Really awful. The beverage dispenser breaks. What to do? We need it fixed already. Can't you hear the guy on the phone? I need this fixed now. Well, there's an answer for that, my friends. It is called a delivery drone. And so we're going to send a replacement part out on our delivery drone, and we're going to deliver it using an open source hardware thing that we've been working on called Drone Drop. So Drone Drop is a, let me see if I have a Drone Drop. Forgot to pull that out. I'll just go in my bag of tricks where I have everything in the universe, almost. Here's one. So the Drone Drop is a small drop mechanism that you just add it to your AR drone, and you plug it in through this cable. The AR drone has a USB port hidden away on it, and so you plug in this little tiny USB microcontroller called a DigiSpark. You plug that into this cable, into your servo, connect this to the bottom of your drone, install some Go program running on the drone itself, and now you've got a very, very inexpensive delivery drone made from store available parts.
So if you don't know, the AR drone runs BusyBox Linux. It's on a 2.6 kernel, so, super, super old, right? And but we can still run Go programs on there. So I used a BeagleBone Black to cross-compile a Go program to run on the AR drone to control the servo, which I used some Velcro to put to the bottom of this.
So let's take a quick look at the code. This is the big picture. We finally got there. So here's the code that we're going to use to fly the drone. So we find that a DualShock 3 controller is ideal for flying as far as the home controllers that you can purchase, which is funny because I play Xbox a lot more, and yet I like the DualShock. It just feels so good. So we're going to connect to our MQTT server. We connect to our drone. The drone is itself a Wi-Fi access point, so we can connect to it via Wi-Fi. The joystick, which we connect to using the DualShock 3 configuration. We support a bunch of different joysticks and gamepads. We connect to the drone itself. Again, we're going to send the same exact datagram. That's the same message that's going along our MQTT. And then we calibrate the joystick. This is when the joystick circle press comes in, which if you haven't used a DualShock, that's one of the little buttons on there, then we're going to drop the package. The package will be delivered. Circle press, package deliver. Square press, we take off. We say drone take off. So when he presses the square button, the drone will take off. Then he's going to use the joysticks, the left one, and the X and Y are going to correspond to one axis of motion. The right X and Y are going to correspond to the other. So with the AR drone, it can move forward and back as well as left and right, as well as move up and down 3 dimensions, which is why 2 joysticks is ideal to control, that we have enough degrees of motion. So then this program, the way it works is that if it gets the right motion, it'll go forward. Otherwise, it'll go back. The default is stand still. Same thing with moving right and left, and same thing with its altitude and pitch, and also its rotation. And then we have a little helper function here, which is not actually part of the type, just simply to validate the pitch that it's legit. And then here is the program we're running on the drone itself. So we're actually running the Go program on the drone, as Adrian had mentioned, cross-compiled. So we're using the DigiSpark adapter. Same GPIO adapter. That's a really, really handy one. You use that a lot. MQTT adapter. We're connected to the MQTT server. This time we're connected to the DigiSpark adapter. And we're going to use the servo. That's our drop mechanism. It's just a very, very simple servo. When it gets the drop message, it moves the servo to the 150 degrees position, which will cause it to drop, and then it sends a message back, responding back to headquarters, the package has now been delivered. All right. So, once again, he's going to take off with the drone. And oh, by the way, this is all updating. If you go to brewmachine.herokuapp.com, you should see this all updated in real time. That's brewmachine.herokuapp.com.
So right now, let's signify a fault on the thing here. Let's see if that works. Oh yeah, now there's an error. So okay, cool. So there's an error on our pump. So now we want to send out a delivery. So let's do this.
Now let's move the camera so you can actually see the cool parts.
And you see that man in the corner is our buffer, so we don't hit into the wall.
Thank you, sir, for your efforts on the community's behalf.
Yeah.
In advance.
Yeah. Every little bit helps in the open source community. Yeah.
I don't know. You'll have to talk to the organizers.
Yeah. Let's see if we can get this. Nah.
I think we should turn the lights back on. Because that way you can actually see what's happening.
I think we got it.
Yeah, but we still should turn the lights back on.
This is some adventure, man. All right.
That's better, isn't it? All right.
Yeah, you'll see the drone flying, though.
Which is much more exciting.
So here's the drone now. Oh, no. The box. We got to get rid of the box. There it goes. No. Save it, man, in the corner. That was it. And it
Delivery
delivered it.
drones.
Yeah. So if we go back to the page really quick.
Oh.
Well, now it's available. It worked. You
the
can
drone
believe
is
it.
available again for another delivery. The sun never sets on the beverage dispensing empires.
Yeah, and I got a new notification on my Pebble from the drone itself, which if you go back to the camera, let me see if I can find it. So you can't read this at all, but it says that it was delivered.
I can kind of read it.
Yeah.
Ish.
So the farther away I get, the more in focus it is, but the
and
tinier the letters are.
Type.
So it's sort of like a, yeah, I know. Yeah. So this is your driver's license text right here.
Yeah, I know. Well, there are some new FAA rules about drones, but I didn't read a vision test among any of them. I don't know. It seems like a bad idea.
I'm a conference-rated pilot, though, so.
I am not. So was that fun? Did you guys enjoy that? So we want to encourage you to join the robot evolution, not revolution. Those usually end up quite badly for somebody, especially the humans. So join the robot evolution so that they call you mom or dad instead of fresh food. So check out commander.io. It's also on the Play Store and the App Store. All the source code is on GitHub, so you can check out more at commander.io. Watchbot.io if you want to control devices with your Pebble watch. Cylonjs.com if you want to use JavaScript to program your robotic fleet. And Gobot.io if you want to build a delivery drone. Thank you very much.
So we do have some time for some questions if anybody wants to ask.
Yes.
Yeah, so the question was if our slides are going to be available online.
And the answer is yes. So we do all our slides in HTML and JavaScript, since we believe in JavaScripting all the things, even when you maybe don't have to. I believe it's GitHub/hybrid-group/presso-SCaLE13x. We will tweet it. And we'll also publish a PDF file for those of you who don't want to get all hipster. Yes, sir. Yes. How did you do that wonderful webcam embedded is a question that I get often. The answer is MJPEG streaming to the browser, and you take a look in there. It's I also have the bash script with which I start out the video. Yeah, that's a nice. Otherwise, I used to do it with a separate window, and it was like always embarrassing because it would have old pictures of me that I had snapped as stills. I couldn't figure out how to get cheese to get rid of them, and it was really cheesy.
It was cheese.
E. Uh, yes.
Does
Any
anyone
other
else?
questions? To the bar. Thank you, guys.
Yeah.
And beyond. Exactly. Nice.